Uh, Today we are going to discuss about one of the important topic. Okay, that is an IPsec. Someone should mute your mics. Okay. Yeah, guys. Yeah, today we are going to discuss about one of the important topic in network layer. Okay, which is an IPsec. IPsec means Internet Protocol Security. Okay, మనకి L3, okay, L3 means we have a network layer, right? We don't have any security for L3. So what they did is they come up with a solution. Okay, మనకి ఒక సైట్ నుంచి ఇంకో సైట్కి L3 ఇన్ఫర్మేషన్ నెట్వర్క్ లేయర్ ఇన్ఫర్మేషన్ సెండ్ చేయాలంటే దెర్ విల్ బి మెనీ డివైజెస్ ఇన్ బిట్వీన్ from one side to another side. Site means let's take you have an XYZ company. Okay, you have one company and you are one of your site. Okay, మీ ఒక ఆఫీస్ బ్రాంచ్ ఆఫీస్ వచ్చేసి హైదరాబాద్లో ఉంది అనుకుందాం, ఇంకో బ్రాంచ్ ఆఫీస్ వచ్చేసి బెంగళూరులో ఉంది అనుకుందాం. సో you have to connect if you want to exchange information, you have to connect to two branch offices, right? Like through the ISPs. Okay, if you want to send in any information from your Hyderabad branch office to Bangalore branch office, you need to send via all these ISPs, where everyone will be the traffic will be flown through the internet and reaches ISP, and again it reaches internet, and it will reaches from Bangalore ISP, then it will reaches your Bangalore site, right? So through this, through that whatever the traffic flows through the internet, there will be a no security. If no security, and there will be a chance of stealing your information. Okay, for suppose you are sending some important data which others not to see. Okay, so in order to protect your data, you have to build an one tunnel between your two sites. Okay, one of you in between your Hyderabad site and Bangalore site, you need to build your tunnel between these sites, so that whatever the information is sending from Hyderabad site to Bangalore site, or between Bangalore site to Hyderabad site, it will be protected and no one else will be seen. Okay, and we your data whatever sending from between the sites, that will be protected, and no one will be seen. So in order to achieve that, we need to use IPsec, so which is an internet protocol security. Okay, this IPsec will work on the layer 3. Okay, this is especially for the layer 3 in order to protect our network layer. Okay, so our agenda of this class is we need to know IPsec. Okay, I already discussed about IPsec. We'll discuss one more time. And అదే విధంగా మనకి ఇక్కడ ప్రోటోకాల్. ఓకే, వాట్ ఈస్ ద ప్రోటోకాల్ ఈజ్ IPsec using. Okay, what are the phases, how many phases are there, and what are the modes in those phases, and these are the IPsec modes. Okay, and what is the other protocols that IPsec is using. Okay, see here, the IPsec is a framework that helps to protect IP traffic on the network layer. Okay, this is mainly working on the network layer to protect the layer 3 traffic, or layer 3 data, whatever sending between site to site. Okay, because IP protocol doesn't have any security feature, IPsec can protect our traffic with the following features. So how the IPsec will protect the layer 3 traffic means these are the four features that IPsec will use. Okay, first one is an confidentiality. Okay, how IPsec will use confidentiality, మనకి IPsec యూజ్ చేయడం వల్ల confidentiality ఎలా అచీవ్ అవుతుందంటే, whenever you have built a tunnel between your Hyderabad site and Bangalore site. Okay, let's discuss with our figures. Okay, we'll discuss with the diagram so that you will easily understand. Okay, you have an connection between your Hyderabad site and Bangalore site. Okay, once you have built an IPsec tunnel. Okay, you have built an IPsec tunnel. How the IPsec will be achieved confidentiality. Okay, first one is an confidentiality, right? How the IPsec will achieve confidentiality means by encrypting. Okay, it will do an encryption. Whatever the traffic coming from the inside network. Okay, let's suppose I will also take one PC. For suppose we have the PC like this, and it is connected to our router or the firewall. This IPsec will be configured at the edge of the device which is sitting at the edge of the network. Okay, whatever the device. Okay, whether it is a router or the firewall, we can configure IPsec on the router and the firewall. But in the real time, mostly this IPsec will be configured on the firewalls, because these firewalls are sitting edge of the network, so that they are controlling your traffic, whether it is going outside or inside, coming inside. Okay, so for suppose the traffic coming here. Okay, let's suppose you are pinging from this machine to any of the machine that is sitting inside this Hyderabad site. Let's suppose this is Bangalore, and this is Hyderabad. Okay, for suppose the traffic coming here from here. Okay, you are pinging this PC and traffic comes here. Once the traffic comes here, what will do is the firewall or the router will check whether it has to pass through the IPsec tunnel or not. If the traffic has to pass through the IPsec tunnel, what it will do is first it will do an encrypt whatever the data that it will come. It will do encrypt here. Okay, it will encrypt. For suppose you are sending a message. Let's say, hi, I am so and so. Okay, okay, that message will be encrypted. Okay, encryption in the sense the converting our plain text into some cryptographic. Okay, cryptographic means we have a set of special characters that will be hi, hello, I am so and so, that will be converted to some special characters, so that no one can be if no one can be able to identify that what it is. Okay, the peats which are formed the IPsec tunnel, they only able to do that. Okay, once the firewall sends this receives this traffic, it will do an encryption, and it will tries to send out. Okay, this is how the confidentiality will work here. The confidentiality will achieve by encrypting the data. Only the sender and the receiver. Okay, let's suppose this is sending the traffic and this is receiving. Okay, your Bangalore site is sending and Hyderabad site is receiving. Only the sender and the receiver will able to read that. Okay, because here we are encrypting here. Once this packet reaches here, the Hyderabad site will decrypt that. Okay, apart from that, anyone sitting on the network and tries to read that, they won't be able to understand, because that was encrypted in a cryptographic form. Okay, this is how the confidentiality will achieve. And next one is an integrity. Okay, second one is an integrity. How integrity will be achieved? Okay, integrity will be achieved by hashing this. Okay, whatever the traffic that reaching here, it will do encryption, and it will be also do an hashing. So okay, it will be calculate some hashing values here. Okay, it will do a hash and it will calculate some values, and it will be sending out. Okay, except the reader, except the sender and the receiver will be able to read and modify. Others who are sitting in the internet, they won't able to modify. Why we are doing hashing means, any one of the user here. Okay, any one of the user sitting on the network, if they tries to capture this packet and tries to modify, they are unable to modify. Okay, because we are already encrypted and hashed with the some values, so that values will won't be modified who are sitting in the uh, internet. Okay, so by integrity we are doing hashing here, so no one in the internet will able to modify any data. Okay, for suppose if you are sending hi, I am so and so. Okay, hi, I am ABC. Okay, let us take they are sending like that. Hi, I am ABC, like that they are sending the message. Once the message reaches the tunnel, what the tunnel will do is the tunnel will encrypting this to some cryptographic from. Okay, let's suppose it will take some special characters. Okay, hi, I am ABC, it will be uh, like this it will be encrypting, and after the encrypting what it will do is, for this it will be calculating some hash values and it will be hashing with that. Okay, once this this Bangalore firewall will, or Bangalore router will send this to the Hyderabad, so that the Hyderabad will be decrypting, and it will also calculating a hashing value. Okay, if hashing value matches, it will be able to see the data whatever it may be here. Okay, and next thing is an authentication. The third thing is an authentication. Okay, before sending the data, what these sites will do is, what these feeds, we can call it as an IPsec feeds. What these IPsec feeds will do is, each other will be authenticating with each other. Okay, the Bangalore site will authenticate with Hyderabad, and Hyderabad site will authenticate with Bangalore, so that they will be able to identify we are sending and receiving the data from a legitimate, or from our exact sites. Okay, so in order to identify that we are receiving the data from our site, so they need to authenticate. Okay, in this authentication we'll be having two types. The authentication will be having two types, which is an pre-shared key, as well as it will be authenticate with the certificates as well. Okay, certificates, here in the firewalls we can be generate certificates manually, or we can get some there will be some third party certificate issuers. Okay, we can get the certificate from there as well. Okay, if you want to use pre-shared key, we can manually configure here whatever the pre-shared key that we are configuring here, we should configure the same pre-shared key here, so that the authentication will be achieved. Okay, and the fourth one is an anti-replay. What anti-replay will do is, anti-replay, even though if we have encrypted and authenticated, there may be some attackers or some hackers, they are using some advanced tools. Okay, మనం ఈవెన్ ఎన్క్రిప్ట్ చేసిన, హ్యాషింగ్ చేసిన, అండ్ అథెంటికేట్ చేసినా కూడా some attackers or hackers will be there using some advanced tool. They tries to steal your data, so, and modify. Okay, by IPsec will use an anti-replay. In the anti-replay they are using a sequence numbers. Okay, these sequence numbers, what it will do is, if any of the data is modified, or data is decrypted, this sequence number will be changed. Okay, so before exchanging, they will be also exchanging some sequence numbers. Thus whatever the traffic sending from Bangalore to Hyderabad, the sequence number should not change. Okay, if the sequence number should change, any if traffic is sending from Bangalore to Hyderabad, in between any of the attackers try to modify it or modified something in the message, and the sequence number will be changed. For suppose the sequence number here is for this data is, let's suppose 12. Okay, and some of the attackers using advanced tools and they have modified. Okay, and that will be and in that case the sequence number will be changed. Let's suppose the sequence number here is an 14. Okay, and it will be sent to the other side. What it will do, it will check the sequence number. The sequence number should be 12, but after modifying what it has happened, the sequence number should have changed, right? So what the Hyderabad side will think that the sequence number is not same, and the data is modified, so it is treating as it as a duplicate, and it will be dropped here. Okay, so that the anti replay will be achieved like this. Okay, using a sequence number, so that any of the modified data is reached, it will check the sequence number. If the sequence number is not matching, it will be treating as a duplicate, and it will be not accept that packet. Okay, so that is why that's how the anti-replay will achieve here. Okay, these are the four features that IPsec is using while transmitting that data from one side to another side. So any of the modifications in this packet, the other side will won't accept. That's how the IPsec will be used in the between the site to site. Okay, between site to site, which VPN will be used means, the between site to site we are using an IPsec VPN. Okay, that is one thing that you need to remember. And yeah, and guys should, yeah. Next thing is an we have types of VPNs. Before that, I will show this. See here, these are the IPsec protocols we are going to discuss, and these are the encryption methods. We have discussed about confidentiality, right? In the confidentiality, we are using encryption, right? These are the encryption methods. And here we are seeing these are the authentications, but these are not exactly the authentication. We will be calling as an hashing, MD5 and SHA the hashing. There is an under DeFi Hellman group where we are going to use in the IPsec. Okay, we will discuss more about that while configuring. And types of VPNs, there are two types of VPNs. One is an remote site-to-site VPN, and second one is an remote access VPN. Site-to-site VPN means we are using between one site and another site. Now we have discussed right. That is an site-to-site VPN. In the site-to-site VPN, we are using IPsec. We have another type remote access VPNs. Okay, remote access VPN means the people who are working from home, right? They want to connect to your network. They want to connect to their office network, so their corporate network. So in that case, the remote access VPNs will work. Okay, they have to connect the VPN first. There is one software. Remote VPN is an software based. Okay, so they have to install their software in the machines, laptops or desktop, and they have to connect the remote VPN, whatever the software they are using. Here in the Palo Alto, there is an Global Protect where Global Protect are installed in our laptops. So if you connect to the Global Protect, then only the secure tunnel will be formed between your laptop and office network, so that they will be able to they will be able to get all this information in a secure manner. If they want to access something from office like pay slips, downloading pay slips, and if they want to mark their attendance, they have to connect to the remote VPNs first, and they need to access. Okay, and proceeding with the IPsec, we have discussed about the IPsec, right? This IPsec, if the IPsec want to establish, or IPsec want to establish a tunnel between site to site, there is one protocol that IPsec is going to use. This is an IKE protocol. In this IKE means Internet Key Exchange. In this IKE, we have two phases. Okay, once we have an IKE phase 1 and IKE phase 2. Okay, once IPsec phase 1 is completed, then only the IPsec phase 2 will start. Let's discuss about IPsec phase 1. Guys, you should have mute someone. Yeah, Naveen. Let's discuss about the phases. Okay, we have IKE phase 1. In the IKE phase 1, we have two modes. Okay, one is an main mode, and other one is an aggressive mode. What will do in the main mode and what will do in the aggressive mode? Okay, in the main mode, first going with an main mode. In the main mode, between our sender and receiver, okay, between sender and the receiver, we are exchanging the 6 messages. Okay, we are exchanging the 6 messages, and in that 6 messages, the first message will be sending from sender to the receiver. Okay, sender means whoever that's sending, whether it is in Bangalore side, whether it is in Hyderabad side, who are sending the traffic first, they will be calling as a sender. Okay, let's suppose your Bangalore site is sending the traffic. Okay, sending or it want to initiate an IPsec. Okay, so it will send an first message. Okay, from Bangalore to Hyderabad, we will be seeing an first message. Okay, in that first message, what they are going to exchange is, let's suppose this is the first message from sender to receiver. Okay, in the first message, what they are going to do is, they will be exchanging some security association parameters. Okay, we'll be calling as an security association parameters. What are those parameters? Means we have discussed about those, right? Encryption, hashing, authentication. Those are the parameters they are going to negotiate nor exchange. Okay, I will be calling as an haggle parameters for easy understanding purpose. Okay, We will be by in IPsec terminology, it is an SA parameters, means security association parameters. But for our easy understanding or remembering purpose, I will be calling as an haggle parameters. What is H means? H means hashing. Okay, it is an hashing. A means authentication. Okay, G means group, whatever the diffie element group that we have discussed, and L means lifetime. For every tunnel or for every phase, we will be having certain lifetime. Okay, and E means encryption. Okay, these are the parameters that are going to exchange in the first message from sender to receiver. Okay, whatever the parameters that are exchanging in first message, the receiver will also send an the in the second message the same parameters the receiver will send to the sender. Okay, for this is from receiver to sender, and the same haggle parameters or security association parameters will be exchanged. Okay, why we are going to exchange these parameters means whatever the parameters we are using. Okay, in the hashing, if you are using MD5, okay, the same should be in the the same should be using on the other side as well. Okay, if authentication we are using pre-shared key, we should be use an authentication as pre-shared key as well. Okay, if group we have a group DH 1 2 3 up to 20. Okay, if you are using group 20, you have to use an group 20 here. Okay, why we are matching this means if parameters is matches, then only the phase 1 will come up. Okay, phase 1 tunnel will come up. If parameters is not matching, any of the 5 parameters is not matching, for suppose if you are using MD5 here, and in this we are using SHA. Okay, these are the two hashing parameters. If you are using MD5 and here using SHA, okay, this parameter hashing parameter is not matching, right? So it will say that the parameters is not matching, and there will be no phase 1 tunnel will come up. Okay, if you want to bring the phase 1 tunnel up, the all the parameters should match, all the 5 parameters should be same on both sides. Okay, these are the parameters going to exchange in the first two messages. In the third message, what it will do is, in the third message it will be exchanging the key exchange. Okay, it will be useful to form an diffie element group. Okay, and in the fourth message also, it will be, it is from, this is third message is from sender to the receiver. Okay, first message it come from sender to receiver, second message receiver to sender, third message is from sender to receiver, and fourth message is from receiver to the sender. It will also send an key exchange. And in the fifth message, okay, this is important, in the fifth message they are going to what we call they are going to exchange some identifications. Okay, identity. Okay, they are going to exchange identification. So in that identification, what they are going to is, they are going to send some sensitive informations like user credentials. Okay, user credentials as well as our private network IPs. Okay, so in this identification, what the sender and receiver will exchange, right? They will be exchanging some user credentials and some private IP address. Okay, so this fifth message should be an encrypted form. Okay, this is because we are sending some sensitive information in the fifth and sixth message, right? The fifth message from source to the from sender to the receiver, it will be an encrypted. The same message will be sending from receiver to the sender in the sixth message. Okay, it will also send its user credentials and private in private IP information. So the sixth message is also in the encrypted form. Okay, in the, see here in the main mode we have six messages, right? In the six messages, the first two messages they will be exchanging parameters. In the next to two messages will be exchanging key exchange, and after last two messages will be user credentials. Okay, identification, for the identification purpose they are sending user credentials and private IPs. So those private IPs should be a sensitive, right? Private IP and user credentials should be a sensitive information. So that's why what main mode will be doing is it will be encrypting. Okay, the fifth and sixth messages are encrypting, so that is why the main mode is secure one. Okay, we'll be calling as a main mode is a secure mode because the fifth and sixth messages are encrypted. Okay, if this is all about the main mode. If I want to tell you about the aggressive mode, okay, we are going to discuss about aggressive mode now. Okay, in this aggressive mode we have only three messages. Okay, we have only three messages, and in the first message itself, the first message is from sender to the receiver. In the first message itself, whatever the we are sending here in the haggle parameters, key exchange, in the identification, what aggressive mode will do is it will send all those in the first message itself, the haggle parameters and key exchange as well as identification. Okay, these all the parameters, key exchange and identification information will be sending in the first message itself. Okay, in the second message is from receiver to the sender, the same the haggle parameters, key exchange, identification will be sent in the second message from sender to the receiver, and also it will be sending some acknowledgement. In the third message is from sender to the receiver, it will be just acknowledging this with some encrypted the with encrypted format. Okay, we don't know what this part. Okay, but here what is main difference between main mode and aggressive mode means, in the main mode we are encrypting our identification, right, our encrypting our sensitive information whatever sender and receiver is sending. But in the aggressive mode we don't have any such type of encryption. We are just sending an identification information in a plain text. Whatever we are sending here, it will be visible to everyone if they grab that packet. Okay, if they grab the packet, they will be able to see the sensitive information. Okay, so here in the main mode, what is the main difference means, the main mode is secured one because it will be using an encryption in the fifth and sixth message, but there is no such type of encryption in the aggressive mode. So what we are using whenever you are configuring IPsec between site to site, the main mode will be mainly used. Okay, the main mode will be mainly used between site to site, not the aggressive mode. Okay, if you want you can also configure an aggressive mode, but by default if you are configuring IPsec phase 1 tunnel, the main mode will be used. I will show in the packet capture. Okay, it will be taking the main mode while configuring phase 1 tunnel. Okay, this is all about the main mode and aggressive mode. If you want to know the difference, here itself. Okay, in the main mode we have 6 messages, in the aggressive mode we have only 3 messages. Okay, and in main mode is an slow process because it has to process all the 6 messages, so that's why it is a slow process. But aggressive mode is a fast one. Okay, because it has only a 3 messages, and the main difference is main mode is an encrypted secure method because of this encryption. Fifth and sixth messages are encrypted so that it will be protecting our sensitive information. And the aggressive mode, there is no encryption, so it is not an secure mode. That's why we are going with main mode in the phase 1. Okay, by default or obviously it will be whenever you are configuring IPsec phase 1, it will be going with a main mode. Okay, these are the main difference. And the next thing is an phase 2. Okay, here until unless the phase 1 is formed, the phase 2 won't come up. Okay, let's suppose we have there is an some parameters mismatch and phase 1 is not formed. So if phase 1 is not formed, phase 2 won't come up or phase 2 won't send any information. Once phase 1 is formed, the phase 2 will be the phase 2 will be sending the information. And this phase 1 is mainly for sending our information. Okay, sending our phase 2 information. And the phase 1 will be found mainly for the management traffic as well as sending in phase 2 information. Okay, So in the phase 2 we have only one mode, which is an quick mode. Okay, in the quick mode we will be having three messages. Okay, we will be having three messages, but all the three messages are in encrypted format. Okay, encrypted form. We can't see whatever the information that we are sending in a quick mode. Okay, here in the quick mode, why all the three messages are encrypted means, I have told you, right, the phase 2 information will be flown, will be transfer only when phase 1 is formed. Okay, so if phase 1 is formed, we have already formed one tunnel between site to site, our Bangalore site and Hyderabad site, and within that phase 1 tunnel our phase 2 information will be transfer from site to site. So that is the reason here our all the three messages in the quick mode in is in the encrypted form. And also if that is the encrypted, there has to, if phase 2 is has to come up, there has to some parameters needs to exchange. Those are the parameters we are calling as an I'm calling it as an pagel parameters. Okay, what are the pagel parameters means? P means here in the phase 2 we are going to use an protocols. There are two different protocols in the IPsec. One is an ESP and other one is an AH. Okay, and in that A means same authentication, G means group, L means lifetime, as well as E means encryption. Okay, these are the parameters that are going to exchange between site to site. Okay, between Bangalore and Hyderabad site in the quick mode to form an IPsec phase 2 tunnel. Okay, if you need to phase 2 tunnel, it has to be the exchange these parameters, but we can't see. Okay, we can see these phase 1 parameters, but we can't see these phase 2 parameters. Okay, because it is already flowing in the phase 1 tunnel, which is an already encrypted one. Okay, so we can't see, but if you want to form an phase 2 tunnel, the sender and the receiver has to exchange these parameters in phase 2. Okay, so first one is an protocol, ESP and AH. Second one is an authentication, group, lifetime and encryption. Okay, these are the parameters that are going to exchange. Okay, this is about phase 1 and phase 2. Do you have any clarifications, or do you need any? Do you have any questions on this between phase 1 and phase 2? Anyone? Yes, phase 2 are different parameters only. The parameters should be same or should not be same on phase 1 and phase 2. Okay, మనం phase 1 లో యూస్ చేసే పారామీటర్సే phase 2 లో యూస్ చేయాలని రూల్ లేదు. ఓకే, యూ కెన్ యూస్ డిఫరెంట్ పారామీటర్స్, బట్ site to site. Okay, but in one side, if you are using one parameters, and if you are using you have to use the same parameters on other side as well. But if you are using phase 1 parameters, it is not necessary to match the same parameters on phase 2. You can use different parameters as well. Yes, same. Remote sites in sense, క్వశ్చన్ క్లారిటీగా లేదు, ఒకసారి క్లారిటీ చేస్తారా క్వశ్చన్? అవునవును. లేదు లేదు, యాక్చువల్గా ఐ రిమోట్ సైట్లో మనకి ఓన్లీ ఇట్ విల్ గో విత్ అన్ ఫేజ్ 2. ఇట్ వోంట్ హ్యావ్ అన్ ఫేజ్ 1 ఇన్ ద రిమోట్ యాక్సెస్. యా. ఎనీ అదర్ క్వశ్చన్స్? Yeah, I will take it as no, and we will be discussing about the protocols now. Okay, what are the protocols? మనం ఈ ఐపీసెక్లో ఏమేమి ప్రోటోకాల్స్ యూజ్ చేస్తామన్నది ఇప్పుడు డిస్కస్ చేద్దాం. There are two protocols that are using by the IPsec. One is an ESP, okay, and other one is an AH. Okay, మనకి వన్స్ మనకి ఏమే phase 1 phase 2 టనల్ ఫామ్ అయిపోయిన తర్వాత ఇట్ విల్ ఫార్మ్ అండ్ సెక్యూర్డ్ లేయర్. ఓకే, ఇట్ విల్ ఫార్మ్ అండ్ టూ టనల్స్ which will be using, see here, the phase 1 will be formed to send an phase 2 information. Okay, the phase 2 tunnel will be formed to send our actual data. Okay, our actual data means if you are pinging, let's suppose you are trying to ping from here to here, but before that we have already found phase 1, and inside the phase 1 we'll be having phase 2. Okay, our actual data, whatever the ping traffic is there, that actual data will be flown from the phase 2. Okay, in that phase 2 the actual data will be flown using these protocols. Okay, our the actual data will be flown through the IPsec tunnel using these protocols. Our data will be this is our payload. Okay, ESP is an payload where our actual data will be there. Okay, what is ESP means? This is an encapsulation security payload. Okay, and AH means authentication header. What is difference between these two and why we are using it? Okay, and what will be you choose between these while sending an data? Okay, here we are saying these are the protocols, right? If you are saying this as a protocols, each protocol will have its protocol number, right? ESP is a ESP using the protocol number 50. Okay, and AH header will be using an protocol number 51. Okay, remember this, these are the protocols. And in the, if you are using authentication header, what it will is, it will protect, it will be provide authentication and integrity. Okay, authentication and integrity for our data, and there will be a no encryption. But if you are using ESP along with an authentication integrity, it will be providing the encryption. Okay, it will be providing the encryption. So it will be the, whenever you are forming an IPsec tunnel, whenever and after forming an IPsec tunnel, what is the protocol that we are going to use? We are going to use an ESP protocol because it has an extra security and it will encrypt our actual data. Okay, if you are using authentication header, there will be an no encryption for our actual data. So whenever you are creating an IPsec phase 2, we are going to use an ESP protocol. Okay, this is a this is only the difference. It will be provide an encryption, but it won't provide any encryption. This is the basic difference between these protocols. Okay, and it will be using an port protocol number 50, and the AH will be using a protocol number 51. This is a major difference, that's it. Okay, and whenever you are sending a data, the IPsec tunnel will be using an ESP protocol because it will be providing an encryption for our data. Okay, okay, whenever the traffic flowing from the tunnel, and once it reaches here, our data will be in the encryptor. Even though we have phase 1 and phase 2 tunnel, we have to encrypt our data, so we are using that ESP protocol, so that we'll not see what exact the information that we are sending, whether it is a ping, whether it is any sending an file from this site to that site, anything that will be encrypting by ESP protocol. Okay, and apart from that, we have IPsec boards. Okay, don't confuse with IKE phase 1 mode 1, phase 1 and phase 2 modes, but these are different modes that are IKE phase 1 and phase 2 modes, but there are two different types of IPsec modes. One is an transport mode, and other one is an tunnel mode. Okay, why we are using what are transport mode and tunnel modes, and why we are using it means, whenever you configure an IPsec tunnel with an transport mode, what it will do is, see, if you are sending in traffic from one side to another side, let's suppose you have ping from here to here. Okay, once this ping traffic reaches, what the firewall will do means, in the ping traffic, what are the layers that will be seen here? We seen L1, L2, L3, and our actual payload will be there, right? Our ping traffic, okay, ICMP traffic. What it will do is, for suppose if you get some information, like it will be the firewall will getting all the information L1, L2, L3, L4, and after that we'll be having an our actual data. So for suppose the firewall reaches this data in this format, and what it will do is the IPsec will be using mostly for L3 only, right? What it will do is before L3, in the if you are using transport mode, they are not going to add any extra header, okay? Whatever the data it coming, it will be sending in the same way without adding any data, okay? If you are using transport mode, but in the tunnel mode, what it will do is whatever the data it receives, we have L1 packet, L2 packet, L3 packet, and L4 packet. After that, we will be having our actual data, right? So here, if you use a tunnel mode, what it will do is before L3, okay? For suppose if you have L2, okay, L1, L2, before L3, it will be adding a new L3 header, okay? And after that, we will be having L4, L3, L4, and actual data, okay? See here, in the tunnel, in the transport mode, whatever the traffic receiving on the router or the firewall, it is sending as it is without adding any new IP header, right? So, but here in the transport tunnel mode, it will be adding a new L3 header before our L3 traffic, okay? Means it will be adding an extra security for our L3 packet, and it will be encrypting with this new L3 header. Whenever the attackers trying to access, even though we have IPsec tunnels, even though we are using ESP, so if you are using tunnel mode, it will be adding a new L3 header. New L3 header means it will be having some public IP addresses, whatever the public IP address that we have configured here, okay? Whatever the IPsec configuration, IPsec IP address will be there, right? IPsec tunnel IP address that will be included here in the new L3 header, so that it will be protecting our actual data, okay? That's why we are going to use an tunnel mode in the IPsec. Apart from transport mode, we are going to use an tunnel mode, okay? This is tunnel mode we are going to use while configuring an IPsec. Here we are using ESP. Apart from ESP, here we are in the phase 1, we are going to use an main mode. These are the things that we are going to see in the IPsec, okay? Any doubts on this? Before proceeding the lab, do you have any doubts? This lab is for only for the CCNA people, okay? For we have 3 batches here. One batch is from Palo Alto, and one batch is from CCNA February 4th batch, and other batch is for from CCNA February 17th batch, okay? This especially this lab is for only CCNA guys. We have different lab for Palo Alto, okay? We'll be doing that in the firewall. For CCNA guys, if you want to practice, we have an lab in we did in an routers as well, okay? See here, this is my simple topology, okay? Where my Hyderabad site is connected to Bangalore. I have created an IPsec tunnel between this side to side using this interface, okay? Let's start this. I have already configured. I will show you the configuration as well, okay? Guys, if you want the configuration, we have a document in our website. Okay, if you go onto the CCNA training videos, there will be a document with IPsec. You can go through that document, and in the last two pages, we'll be having a configuration as well. Okay, you can go through that configuration. You can configure accordingly. so that you will be able to understand. I will tell you what needs to be configured. Okay, we need to configure first phase 1 parameters. See here, this fast Ethernet 0/0 is for connecting to a PC, and gigabit Ethernet 3/0 is connected to other side. If you want to see the configurations, show running config section crypto. So in this crypto, we have already configured phase 1 and phase 2. Okay, this crypto ISACAM policy 1. Policy 1 is for the phase 1 parameters. Okay, the phase 1 parameters here we have configured, and we are using this address. Okay, this is the peer IP address, and these are the parameters that are for the phase 2. Okay, here in the phase 2 we are telling that we need to use an ESP, and this is an encryption, and we are using authentication and hashing here. See here, for the authentication on the phase 1 we are using an pre-shared key, and all the configuration, okay, whatever the phase 1 configuration configured here, you should match on the other side as well. Okay, I will show you on the other side as well. What is the time, guys? I think the meeting will end in 2 to 3 minutes. Okay, please join back. We have only limited time. This is not an subscription meeting. This is a free meeting, right? It will give only a 60 minutes. Maybe it will be end in 2 to 3 minutes. Please join back for all the guys. Okay, for CCNA maybe it will be complete in 5 to 10 minutes, but for Palo Alto we'll be having 1 more hour. We'll be configure that in the firewalls as well. Okay, see here, on the one side we have seen that we are using 3DS MD5 pre-shared key and group 2, right, on the phase 1. Here also same, the parameters on the phase 1 should be same on both sides, and also the phase 2 parameters should also match, okay, on both sides. But there is no necessary configuring same parameters on phase 1 and phase 2 on same side. You can configure different parameters as well. Okay, and after that we are see here we are making a mode IPsec mode as a tunnel, and whatever we are doing is we are creating one here we need to create one policy. Okay, we need to create an ACL, so that we need to tell whatever the traffic means, this traffic, this 10.10 traffic and 20 traffic reaching the firewall should allow. Okay, you need to create that ACL as well. I think here we don't have an ACL configurations. Show running config section, and we'll be having the command. Yeah, see here I have created an access list. Okay, extended access list, and I have permitted the subnets. Okay, I have permitted 10.network 10.0 and 20.0 network in that ACLs. So whatever the traffic reaches on the routers, it will be seeing these ACLs, and it will be allowing the IPsec tunnel. Okay, and apart from that, what you have to do is you have to create C maps, means crypto maps, and you have to set the peer. You have to tell that what is the peer, and what has to match. Okay, we have created an crypto ACLs, right, with VPN traffic. We have to call this as well. Okay, and after that we are creating a crypto map with CMap, and that will be assigning on the Ethernet, our gigabit Ethernet. Okay, show running config section. We don't have. What is that IP? See here on gigabit Ethernet, what we are doing is whatever the crypto map that we have configured, and we have mapped that. Okay, we have mapped that crypto map here, so that all the traffic related things, okay, IPsec traffic related things, that will be flown here. Okay, if you want to verify that, okay, if you want to verify that if IPsec phase 1 and phase 2 is up, we are using show ISACamp. We have sorry, we have show crypto ISACamp SA. This is for the phase 1. Okay, if you want to see, there is no phase 1 tunnel is up right now, and if you want to see the phase 2, show crypto IPsec SA, it will show the second, okay, phase 2. Okay, for now there is no traffic going on. Okay, one thing you need to remember is whenever there is traffic is flowing on the tunnel, then only the tunnels will come up in the initial phase. Okay, in the initial stage, whenever you are configuring initially new configurations, the phase 1 and phase 2 tunnels will come up only when there is an traffic flowing through the tunnel. Okay, when traffic flowing through the tunnel means our interesting traffic, okay, whatever the traffic that we are initiating here, that has to be flowing through the tunnel. Okay, what I do is to build up to bring the tunnels up, I will be pinging from 10.10 to 20.10. Okay, before that let's see if we have IP configuration here on the PC. Show IP, it will show. Okay, there is no configuration, right? You need to configure IP 10.10.10.10 and subnet mask 255.255.255.0, and default gateway is our 10.10.10.1. In the same way, you need to configure same on the other PC. IP 20.20.20.20 and subnet mask 255.255.255.0, subnet mask 255.255, sorry, default gateway 20.20.20.1. Okay, see here we have configured an IP addresses here. Let's try. We have verified, right, there is no tunnels up, and I am going to take the packet capture. Let's see if our IPsec captures will be seen here. I am starting the capture. Let's ping from 10.10 to 20.20. Okay, ping 20.20.20.20. See here, the first one will be timed out, but we got an reachability. Okay, and let's go ahead and check on the routers as well. If you had see the IPsec tunnels are up or not. For IPsec phase 1, we will use and show crypto ISACamp SA. Just click on OK. See here, now the phase 1 is active, right? The phase 1 is active here. And if you want to see the phase 2, you can go with an IPsec SA. In the phase 2, before we don't have an inbound ESP and outbound ESP, right? Sorry. Now the traffic is flowing, and we have the IPsec tunnels up. The phase 1 is up. Now the phase 1 is active. The phase 2 is also active. If you see here, inbound ESP, because we are using ESP. right? Not AH. We are using ESP protocol. So it will be inbound ESP should be active and outbound ESP also should be active. If you want to verify, you have to verify that. And also you need to check the encapsulation and decapsulation bytes here. Okay, we'll be having encapsulation decapsulation bytes here. Okay, you need to check this one as well. If the tunnels are up, you can see this encapsulation decapsulation byte will increase. Okay, see here, now the encapsulation decapsulation byte is 4, right? Whenever we are sending a traffic, we are pinging, right? The traffic is flowing through the tunnel. This encapsulation decapsulation bytes will increase. Okay, see here, before it is 44, now it is 99. Okay, if you want to know whether the traffic is flowing through the tunnel or not, you have to check this. Okay, encapsulation and decapsulation. Encapsulation means our firewall or our Hyderabad one. Okay, our Hyderabad one sending in traffic out, means sending a traffic out means it will be encapsulated and sending out. Okay, what are the decapsulation means the traffic is receiving this router and that decapsulating the traffic. Okay, that's what encapsulation and decapsulation. Okay, encapsulation means we are sending in traffic. Okay, decapsulation is increasing means we are receiving a traffic. If the traffic is sending and if you are not receiving, this won't increase. Only the encapsulation will increase, this won't increase. Okay, and if I want to show in the packet capture, let me disable this, stop the packet capture. And in the packet capture, see here, we yeah, we already had see here, we haven't configured a main mode. Okay, we haven't configured, we just configured a phase one, but automatically between site to site it will take an main mode only. Main mode means we have a 6 messages here. In the first message, if you see, we have a security association, we will be calling as a security association parameters. In the proposal, we will be having transform. In the transform, we will be having whatever the parameters. See here, we are using 3ds cbc, md5, pre-shared key, lifetime. Okay, all whatever the parameters we have configured, it will be capturing here in the main mode. And as well as this is the first message and this is the second message. Okay, the parameters already we have configured and should have matched, right? It will be seen here in the first two messages. And in the next third and fourth message, what we have discussed about some key exchange, right? It will be sending an key exchange here. Okay, this is an key exchange. And third and fourth message should be same. If you see on the fifth message, see here, whatever the identification that we are sending is an encrypted data. We can't see anything in the encrypted one. Okay, and sixth message is also same. Whatever the identification we are sending, that is an encrypted data. Okay, so our IPsec phase 1 tunnel form and our IPsec phase 2 parameters, all the phase 2 parameters, what all the phase 2 messages are encrypted only, because this data will be flowing through the phase 1 tunnel. That's why these are the encrypted one. Whatever we are seeing, we are not seeing anything, right? We are just seeing an encrypted data, and encrypted data. Everything is the encrypted. After phase 1, phase 2 tunnel will be formed. Our actual ping traffic will be flown here. Okay, we will also not see this whatever the actual traffic, because this is also encrypted one. But whatever the ping that we are using here, the ping traffic will be flown from here. Okay, see here, whatever the ping 1 2 3 4 5 6 7 8 means our ping traffic is four messages, right? Four messages means one ESP for reply, one ESP for one ESP for request, one ESP for reply. So we send in 4 packets, right? First time it will send a 4 packet. That's why we are seeing an 8 ESP packets here, from 1.1 to 1.2 only. Okay, because we have made and captured here, but so that's why it is showing an 1.1 and 1.2. Okay, that's all about the IPsec. Do you have any doubts, guys? CCNA guys, someone has raised a hand. Any questions or any clarifications? Yeah. Here in this ACLs, while creating and if you want to allow the subnets, we need to use an wildcard mask. We need to, yeah, particular subnet we need to use a wildcard mask. We have to for that particular subnet we need to calculate the wildcard mask, and we have to give that wildcard mask there. This is in the routers only, CCNA, Cisco routers only, okay. But in the other Palo Alto, we'll be going with an subnet mask itself. Yeah. Any questions? Yeah, guys, if you don't have any questions, the people who are with from CCNA, you can drop off. Okay, I will share the meeting in. I will share this recording after this class. Okay, I'm stopping the recording for now.